Yeah,
Yep.
thank you. Okay, my name is Mark Tehrani. I'm the founder of CyberSec, and here I am intending to explain a little bit about some technologies and tools that we have for post-quantum cryptography migration. I'm going to give you an introduction about cryptographic asset discovery, and also I'm going to give some information about use cases of AI in PQC migration and the risks, and also countermeasures and open questions and research directions for this pathway. So with that said, let's start first with definitions. By SBOM, we mean software bill of material, and they are now mandated in many contexts. They give a transparent and machine-readable list of all software components and libraries. So incidents like log4j could be handled very easily if we have formed a SBOM. And there are standards for that, like SPDX and CycloneDX, and they can also be integrated with DevOps and DevSecOps pipelines. CBOM stands for Cryptographic Bill of Material, and this is essentially a subtype of a SBOM, which is focused on cryptographic algorithms, key size, certificates, and protocols relevant to cryptography. And QBOM is emerging next layer. It tracks quantum relevant resources that systems are using in post-quantum cryptography, like entropy sources or quantum random number generators and these kind of things. And all together are the building blocks of this migration. We have two types of general technologies. The first one is CADI, which stands for Cryptographic Asset Discovery and Inventory, and it's some sort of software asset management tools. It's the process of identification, classification, and recording all cryptographic assets. And ACDI or ACDI's automated CADI takes it further and use AI and machine learning with automated scanning and enable continuous and large-scale coverage and migration. So with that said, let's talk about tools. We have 5 categories of tools in this space. The first one is static code analysis tools. They can scan source codes or binaries, and they will find embedded crypto calls. And this is key for software developers because they are using a lot of libraries, a lot of also open sources, and this is very hard to find all cryptographic dependencies. The second type is endpoint or agent scanners. These are a type of, directly running agents on servers and endpoints. And they can help to uncover every type of certificates or keys or protocols in real environment and in runtime, not inside the code. Third category is network traffic analysis tools that they observe crypto in transit. Type 4 is integrated inventory and agility platforms, and they combine all of these 3, and they help better integrated discovery method be in place and generate CBOM, QBOM, and also provide PQC readiness scopes. And finally, certificates and key management solutions map all type of keys and certs inside the solution and find a bulk of quantum vulnerable asset base that could be target for a quantum aware adversary. So there are these type of 5 tools available, and there are a lot of also research and development. So we are going to show you 2 type of these cases: static code analysis and inventory and agility platform. To do that, I'm showing you also the product that we have. So this product, we call it PostQ. Let me also bring some libraries to show how it works in runtime. It can be connected to all type of repositories and cloud environments. It can make cryptographic architecture, and also it can form QBOM for MLCAM, MLDSA, and SLH, and HQC, which is in standardization process right now. You can introduce your trusted library and also select the library. And Caddy, which we talked about that a lot, is something like this that you can find, for example, you can host it inside your environment on-prem or use it as a SaaS. So here, let's do one Caddy for wallet core. I selected blockchain wallets because they are available. And I want to show you the number of impacts in migration to PQC. So here for this one, let's start scanning. Let's probably, I have to log in again. Okay, let's go to Caddy and let's go to put it here. And also this one, yeah. Okay, so start scanning. When we do Caddy, the Caddy software automatically goes to index everything inside the code repository and find out all cryptographic instances that should be migrated, from the hash algorithms to also all type of cryptographic algorithms that must be migrated if you have AES or any type of symmetric cryptography with low key size and also old and absolute PKIs. So this is one example. Let's take some more. So I'm taking another one here, and I put the name here. So you can see here in the first one, we have 11,315 findings, that all of them are cryptographic measures and code or comment. And it's shocking. You will see that we have a lot of this kind of cryptographic algorithms available in this kind of free open source and available things almost everywhere. So to manage time, I'm not going to do all of them, but I'm taking another one as a Bitcoin wallet, for example, a Sparrow. So let's do that. And then we move to next step. So as I mentioned, this Caddy can always help you to find out all of your cryptographic algorithms. You can find and sort them based on severity or lines or rules or files or algorithm type, or also in terms of if they are a misimplementation or something like that. With that said, let's come back to presentation. The next thing is AI and how we use AI for migration. So AI could be used for migration for finding common vulnerability or common weakness enumerations, or CWEs. These are standardized categories of software and cryptographic flaws that are available in pre-quantum and post-quantum. So something that people don't talk about that is post-migration activities, because there are a lot of activities also after migration, and a big part of that is to find these CWEs that they will end up to CVEs, or common vulnerability enumerations that could make 0 days and problem for migration. So cryptographic migration is not just an update, because it's beyond the scope of an update and patching. It's about finding a good knowledge about all of your assets. And a risk assessment and prioritization is another aspect. AI can help to scan code and detect cryptographic algorithms and help you to score them and prioritize them based on the weakness and the impact and the probability of breaking. And also automated refactoring is something else that you can also use AI to refactor the code to the new one. And also, red teaming is another one because we do penetration testing, but penetration testing right now is not very focused on cryptography. But in future, with this massive overhaul, it must also focus on cryptography. Therefore, red teaming and penetration testing based on cryptography should be a part of use cases of AI, and continuous compliance, because when you migrate the cryptography, also there are overhauls and updates and results of cryptanalysis, and you need to migrate that. So I'm also going to show you a use case of that. Here again, let's go to this example that we already made their caddy. So we are going to risk-based migration. I'm taking the last one. So you can see the risk matrix. So this is calculated by AI. Of course, it's not pure AI. There are a lot of logics for calculation of likelihood and impact per algorithm. But at the end of the day, to achieve how many of them are critical or high risk, or find the total number of risks, is something that we rely heavily on automation using AI. So you can see risk assessment, and also you can see legacy algorithms and the number of instances available in that specific library and the recommended alternatives, and some sort of timeline for migration and testing, and also the risk factors and the impact on availability, or confidentiality, and so on. So I just want to add this, that average global data breach cost is $4.8 million per the latest reports in 2025. Per second of downtime costs $300,000 to $400,000. So if confidentiality or availability is at risk, then this could have a massive impact on economy, and this can be a very good solution to use and rely on AI for prioritization of this kind of risk. For example, let's take another one and see the risk. Let's take the first one because it has a lot of cryptographic findings, 11,000. But let's see how many of them really could make a problem. So I go to share the risk matrix, and you can see we have total 12 risks, that the 2 of them are very high and 7 are critical, high impact and high likelihood. So you can see them and start to study them and make a decision about migration and planning. The next thing that I like to show you is the refactoring, because this is also helpful to make this type of migration very easy. So I'm adding one sample library here. This is this sample. So let's go to caddy first, do the caddy for this one, and call it sample. So in this one, we have just 91 finding in 18 files. And we can see, because it is engineered, we can see it has more type of, med impact, and also high likelihood potential for breach. So let's go to refactoring and see how AI can help here. You can select the name of project. Here it is a sample. You can decide about the trusted library. Organizations at high stake should have their own trusted cryptographic libraries with proper source of entropy. They can use that. They can decide about the algorithm that they want for key exchange or for digital signature. And here I'm just selecting one of them. For example, here there are 7 findings here. You can add them and generate plan. The plan is also generated by AI, and it can give you some sort of patch plan. So you can see, for example, for that specific file, the patch plan was small, but let's take something bigger, and it takes a little bit more time. I add all of the 11 findings and request let's select a library, and then I have to redo that. So I'm going back here and then go for AI-enabled, select the sample, and select the big file, and then set all of the findings, and then go to Wolf SSL and Open SSL, and now request a patch plan. So AI here can also try to help this updating and give you some opportunity. However, it takes more time because of this is a key exchange mechanism that should be exchanged from ECDH to MLChem. And here we will see how AI can help also to do this. So let's wait for a few seconds for that and see how the plan will work. So you can see the patch, and you can also participate in coding and decide if you have to change something. And finally, if everything is acceptable, you can accept it and then move to put it at your GitHub or code repository. So that will be something that AI can help for automated and massive overhaul if everything is well studied and you have a clear roadmap. Coming back to presentation, so there are some risks, and we can introduce some contributors. The first risk is that CW detection can generate false positive. So we have to fine-tune models, we have to sovereign models, and models that are well designed for cryptographic migration. For risk assessment, AI system can operate as black box. So we need a lot of explainability to have a better understanding about the risk heat maps, specifically when the project is massive. And in refactoring also, there is a possibility in breaking dependencies. So it should be integrated with the stress testing and also regression testing and performance testing. In red teaming simulation, AI model can inadvertently expose or leak sensitive data during training or testing and raise confidentiality. So we should have a very good governance on red teaming when we are using AI for red teaming and penetration testing. And for continuous compliance, attackers may deliberately manipulate or evade AI detectors, and therefore they will have adversarial capacity on a tools which is trusted. So we have to think about that angle and protect that. On sovereignty, at the current time, there is no big and very massive AI model in Europe. There are some good ones, but I'm not intending to name any brand. I just want to say that AI could be a double-sided source and sword, and from that perspective, non-sovereign AI models could be a source of exporting code, very sensitive national security level code to somewhere else. From that perspective, sovereignty is very important. And rogue AI also is a possibility that models start to behaving unpredictably. And finally, explainability and also adversarial manipulation and a risk of over-reliance on AI shall be considered and mitigated. I close my talk with giving some research directions and open questions that could help people to see what are the main research questions here right now. So we want to learn for example, CW detection. How accurately can AI-based CW detectors identify cryptographic weaknesses compared to human expert review? And what is the measured false positive and false negative rate? It could be a very good research, and we need to calculate all of the performance indicators. We do that continuously for our product when we are comparing manual results and automated results. So far, we are happy, but this is an ongoing endeavor. Risk assessment also is important because we need also to answer this research question, that to what extent can AI-generated cryptographic risk scores be made explainable and reproducible across different input scenarios and be the basis for prioritization. So this is another research question. Another open question from our perspective is that how often does AI-assisted cryptographic refactoring introduce functional or security breaking or errors in migrated applications, because we do not have a lot of examples in training, and we have to make synthetic data and fine-tune and retrain a specific AI to reduce the error rate per refactor function or module over the time. For red teaming, the research question could be, does training or deploying AI red team models result in measurable leakage of sensitive cryptographic data, and under what condition? This is also a very interesting research question to know on what extent should be worried about, red teaming using AI. And in terms of continuous compliance and adversarial evasion, the research question could be, how resistant are AI-based compliance monitors to adversarial input crafted to bypass detection or depreciated cryptography? Sovereignty also is very important, and supply chain. So research question is, what dependency risk arise from using non-sovereign AI models in PQC migration? And how can we quantify these dependency, and what will be the impact if a lack of service or denial of service or a doomsday scenario happens? Rogue AI question should be, under what operational conditions do PQC-focused AI models demonstrate unintended or harmful behavior, and how often do they deviate from specified objective? It's a very hard question, but we need to answer this if we are going to do massive overhaul, specifically on open source. And finally, last but not least, is cross-cutting risk, which is about explainability, and how does increasing explainability and bring human in the loop to reduce impact of manipulation. So I just want to bring it to end. Our post-Q is following security by design principle. It cover discovery, risk-based, AI-enabled refactoring, pen testing, and quantum randomness, covering standard algorithms. We also have a strong perspective about seeing that holistically as an architecture, because logical view or perimeters like hash functions or symmetric key size or new chem or new digital signature is just the start. There are a lot of protocols like SAML, OIDC, OAuth, SSH, TLS that we have to migrate them. We have a lot of requirements for compliance, and also physical layer is very important. If you use it on TP, SSM, or if you are using some sort of random number generator, this all will be impacted. And finally, CryptoOps and DevSecOps and operational view is quite important. With that said, I'm not intending to give you a big introduction about migration, because it is well addressed by introduction. So the methodology is standard, is everywhere. It must be started with inventory as the first step as soon as possible, and the rest will be clear with risk measuring and road mapping. And at the current time, we are raising fund, and we are also seeking partners to do pilots, and we welcome anyone who wants to use our product for a pilot project and see how it can help for CADI, ACTI, and also risk-based and migration planning. So thank you for the opportunity. On the left-hand side, you can see our academy that will give you an opportunity to receive the migration-specific training. And on the right-hand side, you can follow us, and I would be happy if there is any question to take.